You're taking TCAP this week, aren't you?
Yep.
Okay. How are those?
Is not fun a valid answer?
Yes, it is a valid
Boring.
answer. Oh, is it? It's very boring?
Yeah.
I was listening to the radio last night, and in Illinois, they're protesting those things.
Why?
Just because they think it's a waste of time. They've got a number of parents to sign to opt out so that their kid doesn't have to take them, and teachers don't like them, and I'm not sure what their reasoning is. Their whole purpose, of course, is to, it's for money, financing. Depending on how all the students do on the TCAP determines how much money that school or school district gets.
Yeah, because more people are going to go to that school and pay to go to that school.
Yeah, well, it would mean people are learning a little bit better if everybody did good on the TCAP. So, but how is the math? Is the math hard on it?
No.
No, I wouldn't think so. I would think it'd be pretty easy for you, particularly with us going forward, although they probably don't test much on this algebra that we've been working on.
Yeah, I wouldn't say it's hard, just some questions are worded really weird.
Uh-huh. Okay.
So, it's nothing actually too big.
Uh-huh. All right. This is Chapter 6, or Section 6 of Chapter 5. And, boy, it doesn't look like much. It's the beginning of sequences, arithmetic sequences. And this is not very meaty here. Describe the pattern of the y values. Well, clearly y is 2 there, 4 there, 6 there, 8 there, and 10 there.
Yeah. So.
All right, so I'm not sure what they're trying to say there. The y values are doubling. With every increase in n, the y values are doubling.
Yeah.
Down here we got 1, 2, 3, 4, 5. So on B, with the values of y is the same as the values of n.
Yeah.
And in C, we have 2 circles, 3 circles, 4 circles, 5 circles, and 6 circles. So the number of circles would be what relative to n?
It'd be n plus 1.
Yeah. Okay. It's not much on arithmetic sequences. Let me teach you a little bit more in a more traditional sense. What's the next number in this sequence?
Well, you're just adding 8 each time, so it'd be 14.
Hold on. Yes, I'm adding 3 each time, right?
Yeah.
Yeah. The arithmetic sequence is defined as a sub n equals the first term plus the common difference multiplied by the number of terms minus 1. Now, this might look a little confusing at first, but it's not really.
Yeah.
What's a sub 1 equal to?
Well, a sub 1...
That's the first term.
Oh, yeah.
Okay. What's the common difference?
3.
Okay? So, if I said to you, what is the fourth term? I would say a sub 4 equals the first term plus the common difference times n is 4, so it would be 4 minus 1. That's equal to 11, which indeed is the fourth term.
Yeah.
If I said, what is the 22nd term in this series, what would it be?
Well, a sub so b n minus
What's a sub 1? In other words, start from that.
so if a sub 1 is
Still 2.
Yeah.
Plus the common difference is still 3.
Yeah.
Only in this time n is 22. So it's 22 minus 1. That's 63. Add 2, you got 65. So if I were to go out 22 terms here, I would get that. But notice I didn't need to go out 22 terms. I could figure out what it was. In fact, I could tell you what the 200th term was.
Yeah, you just need to solve the equation.
Exactly. Now, so that's terminology. And this is an arithmetic sequence.
What's the difference?
Well, yeah, I'll introduce you to geometric series here. We have a geometric sequence, which would be, an example would be, what's the next term here?
In the geometric sequence, 20, but
No, actually it's not. Hold on. What's going on? Just a second. What's going on in the geometric sequence? Remember, it's not arithmetic. Arithmetic means that there is a common difference between every term. It's 3 different between every term. Geometric is a different type of sequence. What's happening with the geometric is that every term is multiplied by 2 the previous term. So the next term is going to be 32, and then 64. You're going to double it each time. And if I list the rule for the formula for the nth term of a geometric series, it is a sub 1 times r, called the common ratio, to the n minus 1 power, like that. In other words, if I wanted the fourth term, it would be the first term. The common ratio here is 2. To get the common ratio, you take any term and divide it by the previous term. So that would be 2. N is 4 again, so it would be 2 times 2 cubed, which is 2 times 8, which is 16, which is that fourth term.
okay.
Okay, so these are the 2 most important formulas to remember.
Yeah.
That's for an arithmetic sequence. This is for a geometric sequence. And you're just touching upon this stuff now at your age. You'll get more of this when you get into Algebra 2. And then you'll get more of it in calculus. And in fact, this is some of the hardest stuff there is in calculus. Not arithmetic or geometric sequences, but there's other types of sequences. There's power series. And there are just all kinds of sequences. And understanding them is really quite the trick. But for starters, this will do. So what would the 10th term of this geometric sequence be?
Well, of the geometric sequence, multiplying by 2 every time.
So plug in to that formula.
Yeah, 2, and then n be 2 times 2. 2?
Remember, we got to raise this 2 here is the common ratio, and we have to raise it to the 10 minus 1, so I would raise it to the 9th power, and that's going to be about 1,000. Because I know that 2 to the 10th is just right about at 1,000. I could use a calculator here, but it's not really important to know what the number is. What's important to know is how do you figure out the nth term in these sequences.
And
because
what's important to know is that you know do it.
This formula right there and this formula right there. With those two formulas, you should be able to figure out the nth term in either a geometric or an arithmetic sequence. As long as you know the first term and the common difference, or in this case, you need to know the first term and the common ratio. Okay, so let me give you a different sequence, and you tell me what the next term is. Hold on.
So,
What's the next term?
right here you're multiplying by, no, you're multiplying by 3.
To figure out what kind of series is this? Is it an arithmetic or a geometric?
It's a geometric.
Okay. So what's the common ratio? Figure out the common ratio by taking any term and dividing it by the previous term.
So,
hold on, I screwed up here. This isn't 24. It's 54. There. So if you take any term and divide it by the previous term, what do you get?
3.
-3.
Yeah.
Because if you took -6 over 2, that's -3. If you took 18 over -6, that's -3. So the common ratio is -3, which is cool. We haven't seen that yet. And what is the 9th term going to be?
So,
Here's your formula.
So, A, and which is 8 of 9.
Which means n is 9.
Yeah, 2 times 3.
-3. To what power?
And then 20 minus 1.
9 minus 1. In other words, it's n minus 1, and in this case, n is 9. So it would be to the 8th power.
Okay.
And notice this is going to be a positive number because you're taking a negative number and raising it to an even power. So we would expect this to be big, because if I multiply this number by 3, I've already got 162. So the 9th term is definitely going to be a good sized number. This tells us it's also going to be positive. First term is positive, the 3rd term is positive, the 5th term is positive. All odd terms are going to be positive here. Okay. Let's see what else your big ideas has to say on this. Maybe not much. This is a very, very preliminary introduction into it. Let me look at what else they have here. Oh, here we go. We have, let's look at this 5.4 quiz. Let's see. Hold on a second here. What do we got? Yeah, let's look at this quiz. This might have some questions and exercises that will.
Okay.
That looks pretty straightforward, the first 9 questions, right?
Yeah.
You see anything there that you don't know how to do?
I'm sorry, what was that?
Do you see anything here? In other words, what's number 2? When x is minus 4.
So if x is minus 4, you get 28 plus 3, so negative 28 plus, and then...
In other words, here's what the function is. And when they say evaluated at x equal minus 4, they're saying this. G of minus 4 equals what?
Well, negative 28 plus 3.
Which is?
Negative 25.
Good. Okay. What is G of 0?
Well, G of 0 is 0.
Look again.
3.
There you go. And G of 2?
2 is 7 times negative, 7 times 2, right?
Uh-huh.
7 times 2 is 14 plus 3.
Good. 17. Okay. Now, if I said to you, what is G of x plus 1? What would you do?
Well,
What would your inclination be? I know you haven't learned this yet, so I know you're just kind of guessing, but it's okay.
I'm not sure.
Okay, the idea is that whatever's inside the parentheses gets plugged in for x, right?
Yeah, so, oh!
Like that, which
X
means...
is negative 4, right?
Well, now hold on. No, I didn't ask about a number on this one. In other words, here I was testing x equal 2.
It's 7x plus 8 plus 3.
7x plus 7 plus 3, which is 7x plus 10. So that is g of x plus 1. In other words, it doesn't have to be a number. Whenever they give you a different function inside the parentheses, that's how you handle it, is you plug in whatever they give you for x. So what would g of x squared be?
7x squared.
Plus 3. Okay? So that's what this notation means. And that's why using g of x, or f of x, or h of x is better notation than saying y. In other words, they could have said y here. Right? That's the typical way you see a function written. Y equals 7x plus 3. I know how to graph that. But the disadvantage of using y is that you then can't do what we just did. I don't have any notation that says, well, evaluate y of x plus 1, or what is y of 2. In other words, this isn't really proper to say y of 2. In order to say y of 2, we need this to say g of x, or doesn't matter if it says f of x or h of x or whatever, but this says we have a function of x. In other words, the only variable we're going to see on the other side of the equation is going to be x. There's not going to be a r or a t or a y or anything over there. There's just going to be x. If it was a function of x and t, then I would have x comma t. It would be a function of two different variables. But in this case, it's only a function of one. And so that's why, as you get up in higher mathematics, you'll see this notation much more. F of x, g of x, h of x, n of x. All right, let's talk about this second line here, graphing the function. This, have we done this? I don't think we have.
I think we might have.
All right. We're talking about translations and shifts. Have we talked about those before?
I feel like we did them, but
all right.
I'm not
sure. Well, let me show you what they're talking about here. If f of x, in other words, if the original function is equal to that, compare the graph of these three functions to that. Well, let's do that. Well, g of x, a different function, is 4x plus 1. Well, how does the graph of 4x plus 1 compare with the graph of 4x? Well, here's the graph of 4x, approximately. And here, the graph of 4x plus 1 goes through that point right there. Why? Because it has a y-intercept of 1. This had a y-intercept of 0, right? If you look at these functions as being y equal mx plus b,
okay.
They're linear functions. These two graphs are parallel to one another. If I graph them on the same graph, well, one would look like this. This one would look like that, and the first one would look like that. So what could you say, how would you compare this graph here to this graph here?
The graph to the left, two parallel lines.
They're parallel, for sure, so they have the same slope. What's their slope?
Their slope is the same.
What is their slope?
4x. Well, 4x.
If y equals mx plus b, and m is the slope, what's the
4?
4 is the slope. Meaning I would have to go up 4 and over 1, right? Slope is rise over run. So that's how I knew how to draw it. And the reason these two lines are parallel is because their slopes are the same. If slopes are the same, lines have to be parallel. The only difference between the one on the right and the one on the left is the one on the right has been vertically shifted up by 1 unit based on that. That's what that +1 does. It takes the entire line and moves it up 1 unit exactly.
Okay.
If I want to plot h of x, a different function, but it's similar to our other. It's got the same slope. This one is going to have the same slope, parallel, only it's going to go through that point there.
Okay.
So you would say this curve compared to this curve has been vertically shifted down by 2 units.
Yeah.
And if we look at n of x, it compares with this function up there. It's been vertically shifted down by 6 units.
Okay.
All right, and then we're gonna, let's pick up with 7 next time, and we're going to be talking about similar things, is how these functions compare with this function here. Because in the end, what you end up with is you have about 10 elementary functions. I could think of some. An elementary function would be y equal x. Another elementary function would be y equal x squared. Another elementary function, y equals square root of x. Y equal log of x. Y equals sine of x. These are all elementary functions, and there's about 10 of them. You haven't learned half of them yet. But you've probably learned this one, and probably even this one. Have you learned the square root function?
Nope.
Okay. Well, it's exactly what it says. If x is 4, then y would be the square root of 4 or equal to 2. But each of these is an elementary function and pretty much every function you come up with is some sort of an elementary function that's been shifted, translated, reflected, all of those words. And that's what we'll get into with this chapter here. So we'll pick up from here next time.
Okay.
All right. Well, good luck on your TCAPs. Don't get too bored taking them. All right. I'll talk to you next week, David.
Okay.
Bye-bye.
Thank you.
You're welcome.